multiply, divide, square root, square both sides, base 10, take a log, tangent, take the arctan, baby. Hey, operations, they might be crazy, but use it inverse and solve me maybe.
From the studios of Way Happy, it's Mr. Meyer.
Thank you, Hans, and thank you, our good friends at WSHS, reminding us that inverses help us solve things. And you saw it right there in their beautiful clip that they remind you if it's multiplied, then you divide. If it's added, you subtract. If it's squared, you square both sides. And then you might have seen in that video, the last second, they said tan. Well, then take the arctan, baby. And I love it because that's what we're talking about today. We are talking about how do you find an angle if I tell you what the tangent is, right? Or the cosine is, or the sine is, right? And that's the inverse. We got to inverse these things. So inversing undoes something. And what it undoes is it helps us find the angle that you're talking about. And so you got to be really good at your unit circle. Well, I would call it your hand trick. And you then can tell me what angle I am actually referring to. So a little heads up. The inverse of a sine is called the arc sine. It can be written as sine to the -1. Or I've seen books write it as arc sine like that. In fact, our pre-calc book does. Cosine, inverse cosine is written like that. It's called arc cosine. So you might see somebody write it as arc cosine. And guess what? Arctan is also one that we see. Now, again, it undoes whatever's going on. But really the most important thing to understand is that it finds the angle. So your answer to an arc question is an angle. And that's super important. So look at number 1. Find all the possible values of arc cosine of root 3 over 2. So in other words, the way you read this really is what angle has a cosine of root 3 over 2. So guess what? Grab your hand. Look at it. Remember, cosine is your top fingers. So here's your hand, right? I know. Artist nightmare. Here's your hand. And I want to only see, let's see, it looks like 3 fingers above the hand. So I want to see these 3 fingers. So let's fold this guy down. And so if we fold that guy down, that's going to be our angle. So what is that? If you're in degrees, that's 0.30. If you're in radians, that's pi over 6. So there's your answer. Now, I'm done, right? So the good news is that I would say it's 30 degrees, unless you're in radian, man. You're saying it's pi over 6, and I like both of you, so good job. There's a little catch, though. Remember our all students take calculus? There's actually 2 times that cosine or arc cosine could be a positive answer. So that's kind of tricky. It's right there. It's in quadrant 1 like we found, but it could also be in quadrant 4 where your reference angle would have been positive. So all of a sudden I got to sneak in and say, oh wait, it could have also been 330 degrees. That's a 30 degree reference angle. Or if all the way around is 2 pi and I got to subtract off pi over 6, what is that? 2 pi is 12 pi over 6, so 11 pi over 6. So there's my radians. There's my degrees. You pick one and you tell me which one you like better. That's it. Notice the answer is specifically an angle. Now, funny thing happens is because you're arcing, you actually limit yourself to an answer. So this said find all the possible, and they're leading to a part where if you are going to find an arc cosine problem, you will actually limit yourself to these 2 quadrants, right? If it's positive, you're going to tell me the answer in quadrant 1. If it's negative, you're going to tell me the answer in quadrant 2, and that's going to be it. End of story. If you are finding an arc sine, you will tell yourself, or an arctangent, you will limit yourself to those 2 quadrants. If it's positive arc sine answer, you will then do quadrant 1, and if it's negative, you'll go in quadrant 4 and give me probably a negative angle in degrees. So just a little heads up, because that's something we have to do. So here you go. Give your answer in both radians and degrees and tell me who has an arc cosine of negative root 3 over 2. So again, if you're doing arc cosine, you're sticking to these 2 quadrants, positive answers here, negative answers here. You fold down your fingers and you know that it's a reference angle of 30 degrees. So since I know it's a reference angle of 30 degrees, then and its negative answer, I'm going to give it to you in quadrant 2. So who is that? That's 150 degrees. Who is that in radian mode? In radian mode, that's, let's see, it's pi, but we got to subtract off pi over 6. So if it's 6 pi over 6 minus 1 pi over 6, that's 5 pi over 6. And there's my answer. Beautiful work. How about one more? Let's try who has an arc sine of root 3 over 2. So remember, arc sine is limited to these two quadrants. Either positive answer is there, negative answer there. This is a positive answer. Who the heck has an arc sine of 3 over 2? I have no idea. I think that's supposed to be a root 3 over 2, so a little typo there because we don't know who has an arc sine of 3 over 2. In fact, nobody does. It's illegal. So let's put an root in there, and then we'll go from there. Who has an arc sine of root 3 over 2? So again, sine is your bottom fingers, so make sure you show 3 fingers on the bottom. And if you do that, you have 60-degree angle, or what we call pi over 3 in radians. And there's our answer. Notice I only gave a quadrant 1 answer because the 3 over 2 was a positive number. And end of story. And we'll come back and do an application. All right, excellent work. Now look at this application problem. We got a painter, and he's going to lean his ladder against a wall. So here's the wall he wants to paint, and he's going to throw his ladder up against it. So there's his ladder. And for his ladder, safety guidelines recommend that if you have a ladder, it should be a quarter of its length. That's how far away, at least, it should be away from the wall. So if he's got a 30-foot ladder, there it is, and I need this to be a quarter of that distance. So let's see, half is 15, and cut it a half again. It's 7.5. So he needs that to be 7.5 feet. Then the question is, to the nearest degree, how many degrees is this angle right here? Well, thank goodness for trig. I got a nice right triangle here, and I can look at that drawing and say, all right, let's see, I got the opposites here. Oh wait, the hypotenuse is there. The ADJ is right there. So look, we're talking hypotenuse and adjacent. So that sounds to me like cosine. So the way you would set this up, like always, is you would say the cosine of the angle is equal to the adjacent 7.5 over the hypotenuse 30. And now you're like, sweet, I can solve it. And up until now, we've just stopped at this point. But now we've learned arc cosining. Again, how do you solve? I want to get the angle by itself, just like pretend it's an x. I want x by itself. So we need to get cosine out of here. And what gets rid of cosine? Well, arc cosine. So a little cosine to the -1 right here. And so you got to do that on both sides. Got to put it in front. The arc cosine and the cosine knock each other out, and you're left with theta equals whatever the heck arc cosine of 7.5 over 30 is. Now you're saying, I don't know what that is. Well, that's why we got these fancy dancy Sheilas, right? And so if I go over here to my calculator, and if you look at the cosine button in blue right above it is an arc cosine button. So second cosine, notice it puts arc cosine. I put 7.5 or 75. No, don't do that. 7.5 over 30, and you then close that and you hit enter. Now I'm assuming I'm in degrees, and that definitely does look like degrees, so I feel pretty good. But if you want to check, hit your mode button and make sure you're on degrees in that third one, and I am, so I feel great. It is a 75.52 degree angle is what that should be at. And so we know that this guy is safe. All right. A little more calculator work I can do here too. Just pay attention to this part right here. So they want you to solve. So they're asking me sine in a positive number, and they're saying give your answer between -90 and 90 degrees. So they're just seeing if you know what you're talking about. Here's 0, here's 90, here's -90. So they're saying give your answer in here, right? Well, according to all students take calculus, if you're a positive 0.4, I already know you're up here. So I know my answer's got to be up there. So it's up in quadrant 1 somewhere. So let's see where it is. So what do? I got sine of an angle equals 0.4. If I want to solve this, I'm going to arc sine, baby. Arc sine this side, boom, they cancel out. Arc sine that side, and you get the arc sine of 0.4. You grab your calculator, you second sine 0.4, you hit enter, 23.57. And because they wanted it in quadrant 1, I know that's a good angle. It's not a reference angle because, a little heads up, your calculator will always tell you a reference angle, and that's a little scary sometimes, but not this time. 23.578. 23.578 degrees, and I'm feeling super good. Here's kind of one where you can see it maybe a little differently. Is they want us to find sine of 0.4. Now notice they've changed it. They want it to be between 90 and 360. So they're saying I want you to go from 90 or to 270 to 270. So they want our answer to be in here somewhere. Well, wait, sine's positive. All students take, oh, it's right there. It's going to be in quadrant 2. Now watch what happens, because you'll actually already know I have to arc sine this. So I will arc sine it on my calculator, and voila, it's already done. It's 23.57 degrees. So you're like, wait, how is that possible? Well, that's your calculator giving you what is called the reference angle. Your calculator saying, hey, if this angle's over here in this quadrant, this part right here is 27 degrees, you would have the sine of 0.4. And so now I just got to figure out, oh, okay, if it's in that quadrant, got to do a little simple math. There's 180, and I got to subtract off the 27, and that'll get me whatever this answer is. So now I'm going to just take 180 minus the answer, and I'm done. Now you got to be careful. So 156.42. You got to be super careful because your calculator is a great tool, but it's only so smart. And so your brain has to figure out what quadrant you're in, and you're paying attention, and you know the calculator is giving you a reference angle so you can find it in the right spot. That's it. Have a great day. Stay happy, and I'll see you tomorrow.